Okay, so we are going to look at the derivative of the hyperbolic sec inverse of x. So let's say we are given y is equals to um, hyperbolic uh, hyperbolic sec inverse of x. So we can express this as y being equals to hyperbolic secant of y. Okay, so when you differentiate both sides, you're going to get dx dy, but keep in mind we are differentiating with respect to y, so that's why we get dx dy instead of dy dx. Okay, so the derivative of hyperbolic secant of y, um, we earlier said it's minus uh, hyperbolic tan of y. Okay, I'm using y in this case instead of x, multiplied by hyperbolic secant of what, of y. All right, so meaning our dy dx will be equals to minus 1 over hyperbolic tan of y multiplied by our hyperbolic secant of y. Okay, so we know what our hyperbolic secant is, which is this one here, which is our x, but we want to try to find out what our hyperbolic tan or hyperbolic tangent of y is. So from the identities, we are told that hyperbolic tangent inverse of y is equals to 1 minus hyperbolic secant squared of y. Okay, so meaning our hyperbolic tan, okay, uh, hyperbolic tan of y will be equals to the square root of 1 um, 1 minus secant hyperbolic secant squared of y. All right, so we'll have, if I were to just to finish it here now, I'll say 1 minus instead of me using hyperbolic secant of hyperbolic secant of y, I'll use what? I'll use x squared, simply because I have what? I have an x there. So if I say squared here, even here is also what? It's also squared. So meaning the expression for the dy dx, okay, our dy dx will be equals to minus 1 over we'll have x here, which comes from what? From this part. Then root of 1 minus x squared. So keep in mind to say this is also the same as minus u prime, okay, over here what you're going to have is a u, then we have 1 minus u squared. That's our dy dx. And I keep on emphasizing the u can be anything. It can be sine x, it can be 2x, it can be any function, it can be an exponential, a logarithm or something. Yeah, so that's how you go about that one. Thank you very much for watching.